Now I request to all presenters, please come on stage. One, Sri Kanti Kumar Krishna Sagar, Dr. Mikhil Ranka, Dr. Deepak Madan, Sri Marco Banfi, Sri Binod Kumar, Sri Nilanjan Sarkar, Dr. Pankaj Kumar Jain, Dr. Deepak Manjunath. Now I request to Chairman of Session, Sri I.K. Pandey sir for opening remarks.
Welcome all the participants in this session. The new technologies, innovative materials, methodologies are very, very important for development of infrastructures and fast-tracking the construction practices. And today's we have 16 presentations through which we will be learning the new materials, methodologies, and there are certain softwares as well which facilitate us to fast-track our works with less energy and less effort. With this opening remark, I request and welcome all the participants to make their presentations. In the first instance, in the first round of presentations, 8 participants will take over, and in the next round, we'll take another 8. So in the first participant is for the landside restoration work at Panhala, district Kolhapur, Maharashtra. This is to be presented by Tensar Geosynthetics India Private Limited by Sri Kranti Kumar Shirsagar, Assistant. Thank you. Please take it.
First one.
Okay, sir.
Video automatic हो जाएगा.
वीडियो आपको प्ले करना पड़ेगा, वहाँ पे टच करके हो जाएगा.
I'll just make one request that all the participants should limit their presentation for 10 minutes so that everybody takes enough time to present. Thank you.
Sure, sir. Good evening all. Myself Kranti Kumar and I am from Tensar Geosynthetics India Private Limited, and today I would like to present one of the major landslide restoration work which we did in the last year for the Maharashtra PWD. So here you can see the Panhala Fort is one of the major historical place and tourist attraction in the Maharashtra, and it is located in the south part of the Maharashtra in the Sahyadri mountain range. It is nearly about 20 km from the Kolhapur district. Coming to the failure of slope, the Panhala and the surrounding region was subjected to the heavy rainfall in July 2020-21, and due to that, the lot of amount of water got accumulated in the lake, which we can see at the top. Coming in the right side, you can see the pictures of the failed slope. Addressing the issue for the failure of the slope, we will move to the next slide. Here we can see the vertical cross section of the slope. The failure plane was generally the circular one, and we got the exposed hard rock at a 25 meter from the road top level. 25 meter from the road top level. Here we can see there are water coming from the hillside at the 2 different stages. First one, the water coming from the roadside at a level of near about 1 meter from the road top level, and there is a one drain which carries the water from the lake from the center of the failed slope from the Tanks-Lewis wall. To understand the better arrangement of the drainage system which was present earlier, we will see the plan. There are total 3 drains which carries the water from the hill. One is present on the hill side of the road, second is present on the valley side of the road, and third wall which carries the water directly from the lake. That considering this and the heavy runoff in the past 1 year, in the heavy runoff in that part, and insufficient drainage system. The insufficient drainage system choked that hill surface and the major poor water pressure generated in that part. So due to this, even the 3 drainage systems are there, it was not sufficient to carry the flow of water in the heavy rainfall areas. So the major reason for the failure of slope was attributed to the ingress of water in the hill and insufficient drainage system. So for slope rehabilitation, Maharashtra PWD invited many agencies, but considering all the critical aspects, a technically sound and a structure which can accommodate the existing drainage system, a system that can be constructed within a certain period of time, it was the major important road, was proposed by TENSAR, got finalized. So TENSAR proposed a multi-tiered reinforced soil slope with its proven CRScape system. This system helped us to accommodate the existing drainage system, and it was designed for the future water runoff. Sorry. In the proposed reinforced soil system, we have provided the drain at the top which carries the surface water and the drain at the center of the structure to carry the water from the lake. The drains are provided in such a manner that they will dissipate the water energy because of its flowing. The face angle of the reinforced soil system is maintained at a 53 degree to integrate it with the natural hill slope. Also, the facing provided at the center in a stepped manner to dissipate the water energy. Next. So the proposed reinforced soil slope with the CRScape system comprises of the 2 main elements. One is the TENSAR uniaxial geogrid, and second is the facing wire baskets. So this system performs better in the cases where there is an issue of differential settlement, high seismic areas, and when there is a concern of heavy loads. The fascia comprises of mainly the galvanized steel bars which are arranged and spaced in such a manner that they work very well during the filling and also during the compaction. This type of facing is adjusted with the TENSAR uniaxial geogrid, and you can see the right top corner, the inclined locking element, which helps to maintain the alignment of the vertical and horizontal member of the facing, and also it holds the geogrid. The main advantage is also there for the facing that we can provide with the stone, vegetated or something like that. Next, the proposed structure is analyzed considering all critical aspects by our in-house design software, which is having all conventional design methods and advanced slope stability checks. The proposed structure was analyzed with pore water pressure consideration and the seismic forces. Here there are some photographs of the site that we have got the exposed rock at 25 meter and the JCB is working. We have prepared one level surface and temporarily diverted the water for the ease of construction. Here we can see how the arrangement of facing and geogrids is done. So this is the work at different stage. So this is how the finished surface we got after the completion. So this is from the front elevation. In the right side, you can see how the water is getting step out from the facing. So in this picture, we can better compare how the structure looks after just failure and its completion. So as it is a huge structure, we have monitored it for the last 2 years after its completion using the advanced INSAR analysis technique. From this, we have considered the certain points on the slope and certain points along the vicinity of the slope. So we have observed that there is no movement and settlement during the 2 years. So we have collected the data for same. So I just want to play one short video.
पन्हाळगड ऐतिहासिक व पर्यटन स्थळ असून अंदाजे 3000 लोकसंख्या आहे. पन्हाळगड हे पन्हाळा तालुक्याचे मुख्यालयाचे ठिकाण असून सर्व प्रशासकीय कार्यालय गडावर स्थित आहे. ब्रिटिश कालीन पूर्व कालावधीत पन्हाळगडच्या पायथ्यापर्यंत म्हणजेच बुधवारपेठपर्यंत एकमेव रस्ता होता. बुधवारपेठ ते पन्हाळगडाच्या प्रवेशद्वारापर्यंत 4 दरवाजेपर्यंत पादचारी मार्ग होता. ब्रिटिश कालावधीत बुधवारपेठेच्या दरवाजापर्यंत गडाच्या भिंतीच्या बाजूने कायमस्वरूपी रस्ता बनवण्यात आला. पन्हाळगडास जोडणारा वाघबीळ ते पन्हाळा हा एकमेव रस्ता असून दिनांक 21 जुलै 2021 पासून सुरू झालेल्या अतिवृष्टीमुळे दिनांक 23 जुलै 2021 रोजी सकाळी पन्हाळगडच्या चेक नाक्याजवळील 4 दरवाजासमोरील रस्त्याचा मार्ग खचला व रस्ता तुटून गेला व सदर रस्ता तुटण्याची प्रक्रिया सुरू राहिल्याने सुरक्षेच्या कारणास्तव रस्ता वाहतुकीस पूर्णपणे बंद करण्यात आला. सदर रस्त्याच्या दरीकडील बाजूस पायथ्याशी मंगळवार पेठ बसलेली आहे. सदर रस्त्याचा तुटलेल्या भागाचे मोठमोठे दगड व माती मंगळवार पेठपर्यंत वाहत गेल्याचे दिसून आले. रस्त्याच्या भरावामध्ये 4 दरवाजा, नागझरीकडून येणारे पाणी, गडावरून येणारे पाणी व रस्त्याच्या मागील बाजूस असलेल्या साधोबाच्या गाड्याच्या सांडव्याचे पाणी मुरत असल्याचे आढळून आले. सदर ठिकाणी मुख्य अभियंता, सार्वजनिक बांधकाम प्रादेशिक विभाग पुणे, अधीक्षक अभियंता कोल्हापूर, मुख्य अभियंता व अधीक्षक अभियंता संकल्प चित्र नवी मुंबई तसेच सेंट्रल रोड रिसर्च इन्स्टिट्यूट नवी दिल्लीच्या पथकाचे संशोधक यांनी पाहणी केली. सदर ठिकाणी कायमस्वरूपी उपाययोजना करण्यासाठी निवड केली. ज्यामध्ये 11 मीटरवर कठीण खडक आणला तसेच नसलेल्या भरावाच्या मातीचे परीक्षण देखील करण्यात आले. खचलेल्या भागाची खोली 27 मीटर असल्याने तसेच या भरावात येणाऱ्या पाण्याचा निचरा योग्य करण्याच्या दृष्टीने संकल्प चित्रमंडळाकडून मार्गदर्शन देण्यात आले व त्यानुसार खाजगी तांत्रिक सल्लागार यांच्याकडून आराखडे मागवण्यात आले. यामध्ये त्यांचा कन्सल्टंट म्हणून त्यांनी सर्वसमावेशक आराखडा सादर केला जो संकल्प चित्रमंडळाकडून मंजूर करण्यात आला. सदर तंत्रज्ञानाने होणारे महाराष्ट्रातील पहिलेच काम आहे. या आराखड्यात या खचलेल्या भरावाची रिइन्फोर्स्ड अर्थक्वेक जिओग्रिड सिलास्केट टेक्नॉलॉजीने 4 टप्प्यात बांधणी करणे व भरावात येणारे पाणी सुरक्षितरित्या बाहेर काढणे करता पायऱ्या कॅस्केड करण्याचे नियोजन करून सप्टेंबर 2021 अखेरीस कामास सुरुवात करण्यात आली. ढासळलेल्या भरावातील माती व दगड काढण्याचे काम सुरू करण्यात आले. तथापि कामाच्या ठिकाणी मशिनरी उपयोगी अतिशय कठीण साधारणतः 27 मीटर खोलीवर कठीण दगड आढळून आला तसेच साधोबाच्या काळातील सांडव्याचे 3 दगड आढळून आले.
So that's from our side, sir. Thank you.
Thank you. The question session will take up after all the presentations are made. I mean, the first round of presentations. Now I'll request Dr. Nikhil Ranka, Director, Zytex Industries, to make presentation on next generation technologies for water resistance pavement.
Yes, sir. Please play.
लेजर पॉइंटर है
Laser नहीं.
ओके ठीक है चलिए Thank you. The presentation here today is about next generation technologies, and by technology specifically, material technologies for water resistant pavements. So in order to sort of motivate the problem a little bit first, just have a look at the picture. This is something that, nobody wants to see. And we design pavements to basically avoid this situation, right? You can see in this picture you have cracking, you have a pothole, you have water ponding, you can even see a little bit of stripping on the aggregate. Basically, a lot of different failure mechanisms of how water can damage a pavement captured in one picture. So as we talk about, perpetual pavements and, long-lasting pavements, sustainability in pavements, and basically making more durable pavements, engineers around the world have looked to keenly adopt technologies that can help realize these at an economical cost. And as you can see at the end of the first paragraph, one of the main causes of this has been moisture damage. So as Zydex, our attempt has been to develop material technologies that can holistically address water ingress in every layer of the pavement. And this is a quick snapshot of all the different ways in which water can enter a pavement, just schematically here on the left. But ultimately, what does this lead to? Water entry into the pavement, it can lead to weakening of the soil sublayers underneath the asphalt layers, or over time it can actually lead to weakening of the asphaltic layers if you end up having stripping of the pavement, raveling of the pavement, loss of fines in the asphaltic pavement. So if we break this problem down of pavement distress due to moisture, these are the two main categories. You are going to have weakening of the soil layers or the asphaltic layers, as I mentioned. Tackling one at a time, when you talk about the soil sublayers, you will have a situation where water can get into the soil, weaken the soil, basically drop in modulus of the soil. And the moment the soil layer is not supporting a load because of having water in it, the asphalt layer is responsible for carrying more of the load, and over time it will fatigue and crack. And freeze-thaw cycles, prevalent definitely in some parts of India. It can lead to formation of cavities in the soil layers and subsequent failure. Coming to the asphaltic layers, you can have delamination and what is commonly called stripping. So debonding basically between the aggregate and the asphalt. And you can also, in some situations, have intrusion of moisture into the tack coat or the bond coat layers. So, these are various mechanisms of how water can damage your pavement. So coming to what Zydex has been doing in this area, we are a specialty polymer company that has been a pioneer in organosilane chemistry for pavement applications. And we'll go over precisely what organosilane chemistry is very briefly, but fundamentally, functionally, or the key takeaway, if anything here, is that organosilane chemistry can reduce moisture damage in pavements in all of the layers, in soils and have various applications in soil stabilization, in bond coats, as well as in hot mix and warm mix. So, when we say organosilane chemistry, what are we really saying? What are we meaning? I guess this is a key slide for rest of the presentation. Organosilanes are essentially silicon-containing compounds that can chemically bridge dissimilar materials. So you can bridge organic and inorganic materials. So in the context of pavements, inorganic materials are essentially your stone, your aggregate, cellulose fibers, mineral fillers like lime, dust, stone dust, etc. And your organic materials are bitumen, rubber, asphaltenes, maltenes, etc. So if you can compatibilize these two, inorganic and organic materials, you can create better bonding, you can create better hydrophobicity, and the combination of those two things, hydrophobicity and bonding, can lead to a lot of property enhancements in the pavement. So keep this picture in mind, the picture in the middle here, where you see that organosilane molecule essentially linking or chemically bridging two dissimilar materials. And by using the right organosilane, a surface can be converted to one that will maintain adhesion even if subjected to severe environmental conditions. So, obviously there's not enough time to go through this in a lot of detail, but the result of organosilane chemistry in soil layers is essentially this. You can end up creating very, very hydrophobic soils. And when you can end up creating these kind of hydrophobic soils, you can see here that the water is ponding on the surface. A lot of the properties of cement stabilized bases or emulsion treated bases, etc., are going to improve dramatically. And this is best captured in a quick 30-second video here, where the sample on the left is 3% cement and soil. This is a reasonably clay soil. And the sample on the right is 3% cement plus a certain organosilane in there. So you can immediately tell that the bonding is better and the water permeability is substantially reduced. So the ability of this soil layer now to withstand basically conditions of saturation are going to be a lot better. So intuitively, this obviously makes sense to everybody that this is going to help the pavement. In engineering terms, what does this end up looking like? Very briefly, here is a table that has, this is actual work that we are currently doing based on certain full depth reclamation cores in UP, where you have cement at 4% here, and you have various amounts of organosilane in the remaining three additive columns here. The key thing here to notice is what we're calling here the retained UCS, which is you measure the UCS value, the unconfined compressive strength under dry conditions and under wet conditions. And that retained value basically tells you as to how moisture resistant that particular sample is. So this is a very good proxy test to sort of tell you that a higher retained UCS is a very clear indication of greater moisture resistance in the soil base. And a higher modulus for the soil base obviously has a direct impact on the fatigue damage that happens to the asphaltic layers, and then the overall sort of ESL loading that pavement can endure. So organosilanes obviously can do a lot here for soil bases. Very, very quickly, I'll just go through tack layers and bond coats. This is often a neglected area. Low cost, but highly, highly relevant in order to ensure load transfer between various layers. And nobody ever wants to see a pavement like this, where you have huge amount of tracking happening. So in this area, organosilanes can do something pretty special for you, which is because of their unique ability to create a bond between organic and inorganic materials, you can chemically bond the bond coat to the milled surface. And when you can chemically bond that incoming tack coat to the milled surface, you end up creating basically a trackless tack coat. Trackless tack coat and moisture resistant tack coat. So this is just a picture. You can see here, the truck went over here, but it didn't carry any of the tracks over. So these are some very, very interesting applications of organosilanes to bond coats where you can reduce the tracking. And ultimately, this is probably the most important one, which is that if you can create a bond between bitumen and aggregate, you can prevent stripping of the asphaltic layers. And you can prevent this kind of delamination. And if I have to look at the mechanism of how this happens, you will have a lot of pinhole defects when you zoom in to a coated aggregate. And those pinhole defects is where water ingress is fast and easy. And that's where the pavement starts to get damaged. Organosilanes, by being permanently bonded, can help prevent this problem. Don't have enough time to go through the chemistry, but please do let us know if you are interested to talk later. But fundamentally, chemical bonding and moisture resistance is going to be very, very high. and you will get faster coating, and we've also built in a lot of warm mix properties into this. So really the key conclusion here is that this is a very unique set of materials that is very versatile. It can help you with soil stabilization, it can help you with bond coats, and it can help you with asphaltic layers as well. So you have, one chemistry platform that can do a lot of different things for you. And it's proven, environmentally friendly, and cost effective. So thank you.
Thank you, Dr. Mikkel. Now I'll request Dr. Deepak Madan to make a presentation on utilizing high wrap mixes with Relixure Rejuvenator. He is from Seipat Technologies LLC, Marwag, New Jersey. Thank you.
Thank you for the introduction, and thank you to the audience to give me a chance to talk to you about our product, Relixure. I am with Shripath Technologies out of the USA, and I want to acknowledge Sachin, who's sitting in the audience. He is responsible for the business here in India. So with that, just want to kind of go over into the presentation. Shripath Technologies basically manufactures additives that are used to improve the performance of bitumen and asphalt mixes. Things like rejuvenators, polymeric additives, bitumen softeners, and anti-strip agents. Our core competency is really research and technical expertise that we bring to the table in terms of a portfolio of products that brings solution to the industry. That's what we do. We identify a problem that exists and then find a solution for it. So that's really what our strength is. We are a global company, headquartered in the US as Shripath Technologies. We have affiliates in the UK called Shripath Innovation. In Australia and New Zealand is Shripath Asia Pac, and here in India we have BitPath, that's our affiliate. And then we have agents in South America, in Africa, in Canada. So that kind of rounds up us as a business. Now, let's talk about RAP, Reclaimed Asphalt Pavement. As on a global basis, if you look at us as an industry on a global basis, we generate a lot of economy right now. We are in the mode of increasing the infrastructures in many countries, especially here in India. And as you do that, as you build more roads, you obviously have to rely on more bitumen, you need to rely on more aggregates, but you also generate a lot of reclaimed asphalt pavement, RAP, which kind of starts to pile up if you don't start using it. And Relixure is a very effective rejuvenator that helps utilize high levels of RAP on roadways really around the globe. So it's a way of converting existing roadways into mines and refineries of the future. So, before we just jump into Relixure, I just wanted to highlight one thing. There's a lot of products out there which are really not rejuvenators, they are softeners. And we have to be very careful. A bitumen softener reduces viscosity, but a rejuvenator does a lot more than that. Yes, it reduces viscosity, but it also rebalances the functional properties of the aged bitumen, and it allows it, it regenerates it and allows you to use less virgin bitumen because you can now use more RAP. And there's a number of different types of rejuvenators out there. There's jurisdictions around the world that will use a softer grade of bitumen, when they're using high levels of RAP. There are rejuvenators that are based on petroleum. There are rejuvenators based on used cooking oil. But there's also a family of rejuvenators that are based on bio-based oils that are virgin oils. They're on purpose manufactured and designed to give you some very consistent performance on an ongoing basis. So what does a rejuvenator do? An effective rejuvenator basically is going to penetrate, let me see if I can get a laser beam here. Oops. No, I can't. Okay. Anyway, sorry about that. So what an effective rejuvenator does is it basically penetrates a wrap particle and it rapidly diffuses into it and restores the functional properties of the aged bitumen in the wrap particle. That's really what a good rejuvenator does. So, this is a good flow chart if you're trying to identify a good rejuvenator. Does the rejuvenator soften the bitumen? Okay. If it does, the next question to ask is, can you adjust the grade of your bitumen with this rejuvenator? If the answer is yes, the next question is, does it aid compaction? And the last question you have to ask yourself is, does it have good durability? It's great to have a roadway that is great today when you lay it down, but it needs to have good performance years from now. And that's very critical, and not all rejuvenators can do that. So, talking about Relixir. Relixir is an environmentally friendly product. It's a blend of bio-based oils. It's not a burden on food sources. It's got no volatile compounds, and it lowers both greenhouse gases and the carbon footprint. It's very user-friendly. It's very highly effective, in low dosages. Very easy to use and mix in the plant. It's non-hazardous and it's safe to handle. It delivers excellent performance. It allows you to use high levels of RAP in your mixes, allowing you to basically, helping you achieve your net zero goals that you have in reducing carbon footprint. It improves crack resistance properties and it has excellent durability. That's what sets it apart, is the aging performance. At the same time, it helps you reduce cost, because what you're doing is, by using a high RAP mix where you can rejuvenate the aged bitumen in the RAP, you can use less virgin bitumen, which is really what's driving a reduction in cost. So we developed Relixir back in 2014, 2015 timeframe, and have been selling the product now all across the globe, in North America, in India, in Europe, in South America, in Australia, for many years now. So it has been vetted and trusted around the globe. This is a busy chart, so I'm going to walk you through this. On this table, what you're seeing is 4 mixes: mix 1, mix 2, mix 3, mix 4. And each of the mixes has an A and a B. Concentrating on mix 1, you will see that mix 1 has about 44% of recycled bitumen, and it has no Relixir in it. Mix 1B has also 45% of recycled bitumen, but it has 0.28% of Relixir. And with that addition of Relixir, you can reduce the viscosity from 8,500 to 3,000, while improving the softening point from 80.6 to 61.1. Come all the way down to mix number 4, which has got 83% of recycled bitumen. Without addition of Relixir, you have a viscosity of 47,600, and you add Relixir to it, it drops down to 4,800, and the softening point goes from 223 to 68.9. Just gives you an idea of what Relixir can do. Looking at the clock, I'm going to cycle through very quickly the next few slides so that you gives you a flavor of the different places Relixir is used. This is Illinois Tollway in the U.S., where Relixir is the only qualified and listed rejuvenator on the Illinois Tollway list. This is an example of a trial that we did in Australia using Relixir. Again, it shows you good cracking resistance as well as good rutting resistance. Another trial done in Ireland with two different bitumen levels, with and without Relixir, with and without RAP. And again, when you use a high RAP mix, 60% RAP and Relixir, you get properties that are very similar to ones with no RAP and no rejuvenator. Let me skip through this. I want to end over here. This is just an example of different projects here in India that have been using Relixir, 30 to 60% RAP with Relixir, and this is just a list to give you an idea that this is not a new technology. This is an existing technology being used today all over the globe, including in India. And one last thing I want to mention is the aging performance. And if you look at this slide very quickly, really the key here is, you have an oil, you have a mix with 5% petro oil versus a 5% Relixir, and you can see that even though both the petro oil and the Relixir give you good performance when you pave the road, when you age it, you can see that Relixir outperforms the petro oil. So again, I want to leave that thought with you. Please feel free to contact myself or Sachin. Feel free to scan that OCR code, get his contact information. We're going to be around today, tomorrow, so happy to talk to you guys. Thank you so much.
Thank you, Dr. Madan. Now I'll request Mr. Marco Vanpi from Italy and Sri Ujjwal Gupta, Meerut, SECO, for different solutions for structural devices and seismic isolators.
Hello to everybody. I would like just to, with this presentation, make a quick introduction of what we do, who is our company. Since the time is very, very short, we go through to directly to the presentation itself. So, we as CECO Iran International JV, we are a combination between one Indian company and one international company based in Italy that is expert in this kind of in bearings for or bridge products in general for different kind of products for in this field. In particular, any bridge, of course, has the necessity to carry the loads and to allow the formation and the rotation that are coming from any kind of effect. And in India and in any other country, this kind of bearing are used carrying a different function, mostly related to what are the reaction of the seismic event that are nowadays one of the most critical effects for any kind of structure, of course, but in particular for bridges. So in this kind of devices, the world is basically divided in two big families. The structural devices that in terms of load transfer rigidly the forces on the substructure, or the seismic devices that in the end try to dissipate the energy and anyhow to reduce the effect of the earthquake to the existing structure. Without go too much in the detail, but there are different kind of structural bearings that go from rubber bearing, disc bearing, pod bearing, spherical bearing. There are different kinds that anyhow have different technology to anyhow have the same effect. So to transfer the vertical loads, to allow the displacement and the rotation through elastic deformation of the rubber or to sliding materials, some special material and so on. And anyhow, all these kind of devices can be, as you can see in the table, utilized for different combination, or each one of them has, let's say, its best application in different kind of bridge, so when the vertical load is very high, or where you request some very high rotation, or so on. On the other hand, as I said before, the seismic isolation devices combine all the effects that we saw before, plus the function to dissipate the energy coming from earthquake, basically having two most effects. One is to increase the return period of the structure, and the other one to increase the damping function of the structure. Now I want to just make a quick introduction of what can be this kind of devices, and then to go to one of the important parts that is always related to this kind of bearing, that is the codes and the standards that need to be utilized for their design. So this is one of the main isolators used, that is called lead rubber bearing, and in particular the function of the dissipation of energy is coming from the yellow element that you can see in the center, that is a lead core, and the stiffness, so the elasticity of the device, is coming by the geometry of the rubber element that is, let's say, around the lead core. Another kind of isolator is the friction pendulum, where the dissipation of energy is coming by the sliding of a special material on a surface of stainless steel, while let's say the modification of the period is coming by the movement on the surface on a curved surface. And then there are different kind of dampers or different kind of device that can help to dissipate energy, that of course need to be combined with different kind of device, of course, to follow, let's say, the other function that anyhow they need to be foreseen. And the damper can be for many kinds. It can be hydraulic damper, can be static dampers, and any specific project in general has different application and different peculiarities for which one or another solution can be the best one to be utilized. Now, as you can see, as you can imagine, the solutions are many, and of course any specific project can have different reason or different condition for which one or another solution is utilized. What is very important to drive the designer, or anyhow to drive the decision on which device shall be used, are the codes, the standards that help us to design and to utilize those kind of systems. In the world, there are mostly two standards that are used and that are, let's say, used as defined as a guideline for other standards in the world, including India. So the standards are mostly the European code, that is divided in two parts, the EN 1337 and the EN 15129 for structural bearing and seismic devices, and the American code, which is the AASHTO LRFD for the structural bearing and the gas specification for the seismic devices. In India, for example, there is already one very well known code, that is the ERC 83, that is for the structural bearing. It is mostly inspired on the EN 1337, the European code. On the other hand, for the seismic devices, there is not yet one code that is used in India as a direct Indian code, but for most of the project is referred to the existing one. So the European code for some project, or the AASHTO code for some other project. Now, I just want to give you some brief introduction of what are the things that define those two codes, the European one and the AASHTO code. Now, going through one by one very briefly, because the time is very short, let's say in this way. First of all is who need to be part of the writing this kind of codes. From my point of view, from the point of view of the European code, all the parties need to be involved to do this kind of code in order to let it be easy to utilize for any aspect. So this means the authorities, the university professor, the producer of the isolators, and all the parts need to have let's say a part of this code. And in terms of orientation, also this is very important. In particular, the main difference between the European code and the American code is that the European code is defined as performance-oriented. That means that the devices are defined in terms of what they have to do. So for this specific project, you need certain dissipation of energy, certain functions, so the devices are defined in this way. On the other hand, in the American code, the devices are defined as they are. So for example, one type of device is defined with the peculiar performances of this one, and for example, for the friction pendulum or for the lead rubber bearing otherwise. One of the important parts that also need to be considered for this kind of things or of product is always related to the recentering, because of course these kind of devices give flexibility to the bridge, so give the possibility to have movement in order to dissipate the energy and to absorb the seismic events, and the recentering can be defined also in this case in two different ways between the European code and the American code. From the European code is defined by energy. So in principle, what is to be defined is that the elastic energy need always to be higher than the energy that is dissipated. In this way, we can make sure that the devices will be always able to function in any residual condition they can be. On the other hand, in the American code, what is defined is that the increasing of the force in a certain condition must be higher than a percentage of the vertical load of the mass of the bridge. These, of course, give a certain level of elasticity of the system, but somehow does not give us a response in terms of residual displacement, so in terms of which is the, let's say, the eventual final position in which the devices can be in order to make sure that they can be recentered. Another thing that can be highlighted is about the retaining rings. So the rings that are in general systems that allow the devices to stop or anyhow not to move over a certain limit to guarantee the functionality of the system. These, for example, in the European code are forbidden because they are considered to be a limit of this kind of system that will basically compromise the behavior of the devices themselves, while in the American code are allowed. Another important thing that is to be considered is about the testing. Of course, differently from the structural bearings, where mostly a paper design or anyhow some design should be considered, the seismic devices need always to be tested in very qualified laboratories in the world, and the two most relevant are in San Diego in US and in New Center in Italy, where all the devices need to be tested with a certain percentage of the devices that are manufactured. Typically, for the American code, always for all the kind of devices need to be tested at 100% of the devices that are supplied, while for the European code, there is always a difference between 2% to 20%, depends on which is the kind of the device that is considered. And here, to conclude, is a list of what are the devices that are on the market that are known, with differences, even in this case, about the function that they may have. And one last thing that I just want to mention is about the possibility to develop a new product. Of course, it's always possible to develop new product in this kind of field because the innovation is always important. And also, from this point of view, the European code give already one open door to this kind of innovation, while the American code are a little bit reluctant to this kind of innovation. And that's all. Thank you.
Thank you, Mr. Marco. Now I request Sri Vinod Kumarji from CRRI, ex-CRRI scientist, on white topping technology for roads.
Respected chairman and co-chairman of the session, speakers from the dais and delegates, good afternoon. At the outset, I would like to thank Ultratech Cement Limited, who has invited me for delivering this presentation on thin white topping. Ultratech is putting very effort for the promotion and propagation of this technology. And for the last year itself, some 15 to 16 projects have been initiated by their effort, right from the Jammu to Goa and Gujarat to Assam. This white topping technology was started in US in 1990s with a short-term goal for the rehabilitation of distressed and rutted asphalt pavements. We in CRRI started the working on thin white topping with the encouragement of late Sri V.K. Sinhaji, the then DG of MORTH and convener of Rigid Payment Committee of IRC in 2006 and 2007. And in 2008, IRC adopted this technology and brought out the first edition of IRC SP76, which is used for the design and construction of thin white topping. In thin white topping, whatever present form is prevailing in India, that is long-term solution for the rehabilitation of existing distressed asphalt pavements. So we put thin concrete overlays 100 to 200 mm over the distressed asphalt pavement, and design life is 25 to 30 years. So white topping is, if you have a distressed asphalt pavement, then on top of that, you will be putting a thin concrete overlay that is called white topping. Like this, you have existing bituminous layer, which is in a distress, and there is a time for rehabilitation by putting a DBM and BC overlay, but we have another option of putting cement concrete overlay in the thickness of 100 to 200 mm, that is white topping. Normally, if we go for more than 200 mm thickness, if we call it as conventional white topping, if it is 100 to 200 mm, then it is thin white topping. Less than 100 mm, it is ultra thin white topping, which we should avoid in case of road having very high traffic and axle loads. In that case, we should go only for the thin white topping. That means thickness will be between 100 to 200 mm. Special features of thin white topping is that we place a thin concrete overlay over the distressed flexible pavement and then make sockets at closer spacing, at closer interval. Normally in a rigid pavement, the socketing is a regular feature, but we make socket at each 4.5 meter. But here in case of thin white topping, we make sockets at closer spacing with the anticipation, with the expectation that someday these sockets will turn out, will be converted into working joints. Now that time may vary from few days to few months to few years. So, and when they are converted into the joints, then we will have panels of the short size, which will have lesser amount of curling and lesser amount of stresses under the load. That is why thin pavements can sustain. We try to create partial bonding between the existing bituminous layer and the cement concrete overlay, so that if bonding is created, then lower bituminous layer will also give some support to the thinner cement concrete overlay, and load carrying capacity of the thin concrete overlay will be better. Use of synthetic fibers is not mandatory, but you can use them like polyester, polyethylene, polypropylene fibers. Concrete grade has to be the same, minimum M30. We use M40 grade of concrete. For city conditions where you have to open the traffic early, you can go for M45 or M50 grade also. Dowel bars are not provided at all transverse joints, as in case of conventional pavement. Here we will be providing only at transverse construction joint. Similarly, tie bars will not be provided at each longitudinal joint. They will be provided only at longitudinal construction joint. Joint sealing is optional. In case of regular rigid pavement, joint sealing is mandatory, but here it is optional. You may seal them, you may unseal them. This is the philosophy of design. Shorter the panel, which is expected to be created on the ground, shorter will be the curling, shorter will be the curling stresses and load stresses. That's why thickness can sustain. These are the differences between conventional and thin white topping. First is the slab size is bigger in case of conventional rigid pavement. It is very less, 1 meter to 1.2 meter. We hardly go beyond 1.2 meter, but the maximum size can be 1.5 meters square. Then curling stresses are very high, very low in case of thin white topping. Loss of support will be very high in rigid pavement, conventional rigid pavement. That's why we require a thicker pavement to sustain those stresses. So these are some differences. Dowel bars, I already explained, only at construction joint, and tie bars only at longitudinal construction joint. And application, you can use them everywhere for parking lots, for state highways, national highways, city roads, everywhere. And critical stress location, design difference is there. We design these thin white topping on the basis of corner stresses, because it has been seen that whenever thickness is less, corners cracking is more predominant in such overlays. So we design them for critical corner stresses, and we have these equations which are given in IRCSP 76 for curling stresses and for load stresses. And this is the code which was brought out in 2008, and then it was revised in 2015. Construction steps are milling to create a rough surface, then normal placement and compaction, and then finishing and curing. Like this, this was the project from the Bangalore Nice City Road, which is the best kind of road so far, thin white topping. Milling was done, and you can see the bottom photograph. After milling, you will have a very rough surface, and the aggregates are projecting outward. And these aggregates will get interlocked whenever you will place the concrete overlay, and then it will help in the load-bearing capacity of the top layer also. If bituminous layer is minimum 75 mm, then it will have a good support for the PQC. But even if it is less than 75 mm after milling, even then it will provide a good support to the thin concrete overlay over it. So manual roughening can also be done, though it is not recommended, but at smaller projects you can use JCB for creating a rough surface. And then you can place the concrete using fixed form paver or slip form paver. Anything can be done. You have to texture. It is better to go for time texturing. It is a normal feature of rigid pavement. And then to avoid the plastic shrinkage crackings, either you can use polyester or polypropylene fibers, or you should take the extra these measures to spread a curing compound so that plastic shrinkage cracking will not occur. Then go for the normal curing for 14 days, and then you have to make the sockets. Sockets has to be h/3 to h/4 depth, and spacing will be 1 meter by 1 meter in transverse as well as in longitudinal direction. This is the transverse construction joint where you will be providing dowel bars. You will have other joints also, but dowel bars will not be provided. In the bottom photograph, you have this longitudinal construction joint, because one lane has already been laid, then by the side of the second lane will come up, so you have to provide a tie bar at this longitudinal construction joint. Sealing is optional. You can leave them in unsealed condition. The best project of white topping so far in India, which was constructed 12-13 years back, no sealing of the joint was done. I am talking about the Nice Road, and it is functioning perfectly even today. So sealing is optional. You may go for sealing, you may not go for sealing. But whenever you go for the sealing, use proper sealant like polysulfide, polyurethane, or silicone. This is the photograph from Bangalore Nice Road, milling and then a milled surface, PQC was laid with this silicone paver. These are projects from Pune city roads. All have been converted into the, Maxim Road have been converted into the white topping. These are projects from National Highway 848 Nasik Pet, and this is a very good project which was completed in 2020 and performing very well. This is from Gurukul Road in Ahmedabad. This project has been recently completed this year. There was an existing bituminous road which has been converted to white topping. This is another case study from the Rajkot, from Gujarat itself. This few months back it has been completed. Flexible pavement bituminous road have been converted into this thin white topping, which will have a design life or even performance life of 20-25 years. And this is another example of Amravati Road in Nagpur, again converted to thin white topping. And Raigad to Panvel, NH, I think it is NH 66. It is already going on. This project is already going on. And 4 more projects are coming up wherein National Highway existing bituminous will be converted into thin white topping. As far as the cost is concerned, initially you may have to spend 20 to 25% more as compared to the cost of the flexible pavement. But in life cycle cost, if you compare, you will be investing more than double the money if you go for the bituminous treatment, bituminous overlay, as compared to the thin white topping. So thin white topping is a sustainable, cheap, and durable option for the rehabilitation of bituminous and flexible pavements. That's all from my side. Thank you so much.
Thank you, Vinodji. Now I request Dr. Madan from Sripat Technologies LLC to make presentation on improving rutting resistance with bitumen-friendly PGX span polymer. Thank you.
Thank you again for the opportunity to talk. In this presentation, I'm going to talk about one of our other products, which is a bitumen-friendly polymer additive called PG Expand that improves rutting resistance of roadways. I'm not going to spend on this slide since I did spend quite a bit of time on this in my last presentation. So let's look at this this photograph. You have seen this. There's a rutting issue on roadways, not just here in India, but really across the globe. Any place with a climate like this, sees rutting, and what Shripath offers in PG Expand is a solution to help resolve this rutting problem. PG Expand is a bitumen-friendly polymer. It basically gives you PMBs that help you give you good rutting resistance. It is easy to incorporate into the bitumen. It's easy to use. It helps. It really helps with delivering a high resilient modulus, and we'll talk about that in a couple of slides. What it does, while it is delivering all this performance, it is also making the mix easy to pave and easy to work, even at lower temperatures. A very interesting property, a very healthful property. And it's very highly dosage efficient. So it's PG Expand is not an elastomer, it's not a plastomer, it's something in between, and you will see that as we go through the data. It basically is a very bitumen-friendly polymer, and you'll see that in the next slide a little bit more. Short mixing times, lower mixing energy, lower temperatures to mix without the need for high shear mixing. What it does is it delivers excellent properties in terms of rutting resistance while giving you good fatigue properties. It improves high temperature performance without having an impact on the low temperature performance. Very, very dosage efficient, reduces the viscosity. And by delivering a product at a lower energy, you are getting something of a cost savings there, and also using a product that's so highly dosage efficient also lends cost savings. So it again delivers you great properties, is bitumen friendly, and helps save cost. We started the development process here on PG Expand, finished that around 2015, and it has been used, in the US, in Canada, in Australia, in India, in the Middle East, for both paving applications as well as for roofing applications. It's just kind of a unique product. It has multiple applications, and a very interesting product. You can basically melt it into bitumen at temperatures of around 150 degrees, 160 degrees centigrade. It's an endothermic reaction, so you need to kind of continue heating the bitumen to get it into the bitumen. But you can do this using low shear mixers, very little stirring, and in 1 to 3 hours time frame in a production situation. So this basically lends itself to some very unique properties. If you look at the table on the top left, what you're seeing is a grade of bitumen that has been mixed with 1.5%, 2%, and 3% of PG Expand to create PMBs. And you can look at the softening point goes from 48 to 98, 122 to 123. Penetration 67 to 40 in the 45-39 range. Viscosity drops from 450 to 402, 384, 370. The table at the bottom is a hybrid of PG Expand and an elastomer using the same base binder, adding 1.5, 2, and 3% of PG expand to a PMB now, which is a base binder, and 2.5% of SBS, and you see a similar trend, improvements in softening point, improvements in penetrations, improvement in viscosity. As I mentioned, it's not an elastomer, so you don't see that elastic recovery. But it's not a plastomer either. It's a unique product. It's somewhere in between, a new technology, and that's what we are bringing to the table here. Excellent storage stability. If you look at a cigar tube test, you see a very small percentage difference from the top to the bottom. If you were looking at an SBS, that would be 10%. So excellent storage stability. The graph on the left-hand side shows you the viscosity over a temperature range. The top is your binder, the base binder, and the green is the binder with 1.5% of PG expand. And you can see that across the whole temperature range, you have a drop in viscosity. The graph on the right-hand side is compactability. What you're comparing there is a regular mix, not a PMB, a hot mix asphalt using a C320 binder, which is kind of equivalent of a V40, with a PMB with 3% of PG expand, and you can see that the PMB with PG expand is as easy to pave, as easy to compact as a regular hot mix. And then that's really what sets up the product apart from other products. Looking at rutting resistance, the graph on the left-hand side gives you the rutting resistance with the percentage of PG expand going from 0 to 3%, and then you can see as you increase the amount of PG expand, you get better rutting resistance. Graph on the right-hand side generated here in India. The top curve is the base binder. The middle curve is for a PMB with the base binder, the same base binder, and 3% SBS, 3.5% SBS, and the yellow graph is for the base binder with 1.5% of PG expand. And you can see that the PG expand gives you significantly better rutting resistance compared to either the base binder or the binder with SBS. Graph on the left-hand side gives you the resilient modulus with percentage of PG expand going from 0 to 2%. You know, as you add more PG expand, you have an improvement in resilient modulus that allows you to have a better pavement and reduce thickness. Graph on the right-hand side compares the fatigue properties of a PMB with PG expand to a PMB with SBS, and you can see that the two fatigue curves almost are sitting on top of each other, showing that even though you can get good rutting resistance, you get a good resilient modulus, you also get good fatigue performance using PG expand. This is data from India, generated at IIT Bombay. On the left-hand side, you see a lab-based test. You can see the Hamburg wheel test at 40 degrees centigrade, 20K cycle at 5.69, a CT index, ideal CT of 74. On the right-hand side is actually a PMB with crumb rubber as a control versus with 1.5% of PG expand with the same binder, and you can see a significantly better rutting resistance, excellent tensile strength ratio, and excellent resilient modulus. Some examples of testing done here in India. Again, I can see my clock ticking, so I'm going to go in, go to my conclusions here. Really, from a blending perspective, PG expand gives you this ability to get it into the bitumen very easily, very bitumen friendly, a very useful property to have. It's environmentally consuming less energy, does not need cross-linking, and there are no OHS concerns. Gives you excellent performance using very low levels of the material, and very, very highly dosage efficient, kind of, has the warm mix additive properties in it. You don't need a separate warm mix additive, and you can pave and compact it at low temperatures. With that, just wanted to put this back up. If you have any questions, please feel free to ask us. Very happy. You can ask me or you can ask Sachin, who's also here in the audience. Thank you.
Thank you, Dr. Madan. Now I'll request Mr. Nilanjan Sarkar from Tikitar and Cell India Private Limited to present emerging trends in flexible payment materials. Thank you.
This one.
Mr. Chairman, sir, Mr. Co-Chairman, dignitaries off and on the dais, ladies and gentlemen, very good afternoon to all of you. My name is Nilanjan, and I'll be speaking a bit on this topic. This is a very big topic, so I'll constrain myself to two significant subtopics, which are circularity in asphalt pavements and polymer modified binders, mainly next generation ones. If I direct your attention to this slide, this is of course a fact. I just want you to spend a moment on the highlighted portion. See, any long-lasting or very, very long-lasting pavement, especially a flexible asphalt pavement, can be a very, very significant contributor to circular economy in our industry. Now, this is a very insightful slide for me. When I saw it for the first time, see, in this slide, you can see that being representatives or being key stakeholders of the asphalt pavement industry, we have been embedding concepts of circular economy for a long time. It is not something we have started doing today. Yes, there is a huge scope to improvise, but it is not something which is unknown to us. Some of the principles of circular economy, some of the speakers have spoken, and there are many sessions being held parallelly. Like, for example, keeping products and materials in use. We are very familiar with the concept of reclaimed asphalt pavement wrap or using waste as resources. So many papers are presented, and IRC is also at the forefront in terms of publishing guidelines to use. Similarly, our industry, the asphalt pavement industry, as any other industry, it has a very, there is a loop which we go through. It starts off with production or manufacture of the hot mix asphalt, then its installation, then its application, and of course, the end of life. It is here at the end of life that I'll share some examples with you, okay? Now, everybody aspires for long-lasting asphalt pavements. However, when we talk about long-lasting asphalt pavements, it requires different approaches. You cannot build a very, very long-lasting asphalt pavement using conventional approach. Now, some of the approaches could be in terms of its pavement design, using concepts like perpetual pavements, maybe using alternate surfacings, stone matrix, EME. Thank you, Dharamvirji, for reminding us of EME. Now you look at a material like EME. It can be a wonderful material for your bottom ridge DBM2. However, if we look at using VG40 for it, VG40 will turn out to be a very, very soft binder for EME. How to pronounce EME? Please ask Professor. Similarly, mixture design, okay? So if you want to go for a very, very comprehensive mixture design, you can look at concepts like the balanced mixture design. Now, I'm not telling these are the only options. There are multitude of options which you can use together or in isolation. So when you look at, purpose-built asphalt pavements, you talk about perpetual pavements, you have to maintain strain values not only for fatigue, but also for rutting. And how do we do that? Maybe we engineer binders which can actually help us affect that. Similarly, we look at other purpose-built pavements. Say, we look at moisture damage. Some of the speakers spoke about its impact in India. We all know about it. Now you use something like OGFC. That is a mix with 17 to 23% voids. A conventional binder may not be the best choice. Similarly, SMA, something which is getting a lot of traction these days, we need something which can maybe stop drain down, have better film consistencies. Now my question is, and this is not my question, this is something we discuss internally within Ticketar and Shell, at Shell, and also with all of you stakeholders. Like, are conventional polymer modified bitumen capable of managing these aspirations we have? You look at the SBS molecule. This is an invention of Shell. 1967, we filed the first patent for SBS. Similarly, in India, we are quite advanced. My session chairman, Shri Pandeyji, he can tell you how many decades ago we have laid the first section of PMB at Rajghat. So the question is, can conventional PMB be the solution for all applications? And when I say conventional PMB, I even talk about materials such as 76E-10, 82E-10. Today is 2nd of December, and at Shell, we have completed 103 years of being in the bitumen business. I just share with you some snapshots of how we have served some geographies with alternate binders. Now, when you look at SMA, we looked at high viscosity. OGFC may be a very specific porous asphalt. You look at high grades of RAP incorporation, Shell Carifault RC, or something like 1020. So we feel that one of the solutions for longer lasting pavements could be highly engineered PMBs. And one of them I'll talk about is nothing but the Shell Carifault AgeSafe. I'll just play this video, it will just take a moment.
Before, heavier traffic, harsher weather, stricter regulations. These factors are placing a greater strain on our roads, which is why you need Shell Carifault AgeSafe. Shell's next generation formula is designed to help roads last up to 20% longer than regular polymer modified bitumen. By delaying the aging of bitumen, Shell Carifault AgeSafe can extend the service life of roads by up to 3 years. Fewer resurfacings are required, so you'll spend less on road maintenance, while avoiding CO2 emissions by up to 10%. Durable, sustainable, and cost-effective. Shell Carifault AgeSafe is truly making the way forward. Shell Carifault AgeSafe, engine full on.
So we discussed these benefits in the video. I'm not going to run through this, but I just wish to tell you that these benefits are with respect to conventional PMB. They are not in comparison with refinery grade bitumens like VG40. Obviously, you can get the advantage of extended resurfacing. At the same time, we are doing a lot of trials across the world, in the UK, in Thailand, etc. And I am very encouraged by our customers. I hope when we come back next year, we will share data about AgeSafe in India. At the end, we at Shell, we firmly believe in working together. It is not something, these solutions are not available alone with us. We require full collaboration of the industry. And of course, just to summarize, techniques and materials that encourage longer lasting pavements. We require materials with very low carbon footprint and recyclable. And since India is a very large country, we need to use materials which are marginal and not truck around materials. We firmly believe bitumen is, and for a considerable time in future, will continue to be the binder of choice for flexible pavements. With this, I thank all of you to listen patiently to me. Thank you, Mr. Chairman and Mr. Co-Chairman.
Thank you, Nilanjan. May I now request Dr. Pankaj Kumar from IOC, Indian Oil Total Private Limited, not IOC, to present polymer modified bitumen, future of long lasting roads. Thank you.
Good afternoon. Good afternoon, Chairman, Co-Chairman, fellow colleagues and delegates. So Nilanjan has already made my life easy because already he has given the thrust on the polymer modified bitumen. So my talk is also on polymer modified bitumen, future of long lasting road. So just to give the brief of my company, so this is a 50-50 JV of Indian Oil and Total Energy France. This company was formed in March 2021. Previously, Total Bitumen was independently doing this bitumen derivative business. Now this company is doing the bitumen derivative business in India. Coming to the presence, we are available in Pan India, and we have around 6 plants and 9 depots all over the country. So we do manufacture all type of bitumen derivative. It is polymer modified bitumen, CRMB, bitumen emulsions, and NRMB. So this is our product range. So our polymer modified bitumen brand name is Styrelf. So basically Styrelf came from sty, that is styrene, butadiene, styrene, and ELF was the elsewise company name like IOCL. It was ELF in France. So in 2001, Total took over worldwide ELF lubricant, and then it became the Total. So this Styrelf is our patented technology. It is a polymer modified bitumen. So we do manufacture all types of PG grading as well as the IRC SP 2010. So most likely, I think in this IRC, this SP 2010 will also align with the 15462 2019, which we are aiming for. So now coming to directly to the PMB uses and how to promote it. So basically, there are the bituminous pavement, there are the different distresses like fracture, disintegration, deformation. Then there are different type of cracking, fatigue, thermal block, age, longitudinal, reflection, slippages. Then there are different type of pothole, raveling. So what are the cure? Cure may be seal coat, thin overlay, or patchwork. And ultimate, there are the permanent deformation, which is called rutting. The causes may be low air voids, bitumen content too high, excessive amount of natural sand, excess dust, etc., etc. So what are the solution for this pavement distresses? So as per the IRC 37, the table recommend greater than 50 MSA modified bitumen or VG40, and for 2050 BC with modified bitumen or VG40. So we are trying to tell to IRC that VG40 word should be removed from this at least between 20 to 50 MSA, it should be with modified bitumen, and similarly for greater than 50 MSA, SMA should be with modified bitumen, not with the or VG40 word, because VG40 and polymer modified bitumen or modified bitumen are entirely different things. And the way traffic is increasing, by the time the project completed, it is already 150 or 200 MSA. So now coming to our product. So basically this product was designed, is an invention of joint research program with French Highway Department like NHAI in India. So this was the French Highway Department in France. It is a blend of high quality polymers with the unique cross-linking agent, which is our magic formula, which imparts the physical and chemical changes to bitumen, making it much more resistance towards the weather and provide the longer life and riding safety comfort. So how this works, this technology, so it has the elastomer. We use the elastomeric technology, that is SBS. Then we add into the bitumen, and we add in situ cross-linking agent, which is our patented cross-linking agent. So how it works, you can see these are the asphaltenes. When you add the polymer into this, so you can see, when you add the polymer into this, you can see there are different places where oxidation can take place, but when you add the cross-linking agent, it takes care, it ensures that wherever the possible oxidation can occur, it block that places, and how it can be verified through the fluorescence microscope. If you see from the fluorescence microscope, pure bitumen looks like left side, which is a yellow color. Then you add the polymer, which is called physical blend without any cross-linking agent. It is a heterogeneous, but once you add the cross-linking agent, so what will happen, it ensures the uniform dispersion of polymer into the bitumen, provides the 3D network, which is a reversible process, so that when you dissolve this product into the any solvent and heftane, hexane, so it will ensure the same surface which was having like the pure bitumen. It ensures the polymer was completely uniformly dispersed into the bitumen. So this was further verified by the storage stability, which has done for the 4 weeks, where no phase separation was occurred. Similarly, the aging effects, where before aging and after aging with RT-FOT, PAV, these tests were conducted and found the product with the cross-linking agent provide the homogeneous surfaces. So in terms of performance rating resistance by Hamberville rating test, as well as in IIT in India, we have conducted these tests on our styrel. Then performance on fatigue correct resistance with LCPC, that also conducted. And the mixes with cross-linking agent proved that we can increase the 60% fatigue life. And these are some of the films which we form when we manufacture the product. It shows the uniform dispersion of polymer into the bitumen, showing the translucency in the film. And some of the film with the sulfur, so it shows some particles were available. So that's why it shows the difference between the cross-linking agent, what is a patented product of us. So basically, use of modified bitumen, everybody knows it provides resistance toward rutting, thermal cracking, and fatigue. So overall, if you see, PMB is a multi-dimensional, provide the multi-dimensional performances. And if you see, in India, we have already paved more than 3,000 kilometer road with this product. Specification I will not touch. So what does it mean? So basically, initial cost may be high of the polymer modified bitumen, but we have to see the life cycle cost, which is demonstrated in subsequent slide. If you see the cost effectiveness, riding comfort versus the economic evaluation, you will find if you are able to save the 1 or 2 overlay in the cycle of 20 years, like you will be having the sustainable development, as well as you will be saving lot of cost. So we have calculated VG40 against 76 minus 10, where we have shown that for 1 kilometer, around 1 million rupees you can save. So this is our R&D, where we have all the test facility available, and we provide the training on storage, handling and application, technical assistance, laboratory support. So basically what I am trying to say, in India we have 2% national highway, which carries the 40% of the traffic. If we able to pave, if we pledge that we will be paving this national highway with the polymer modified bitumen, we can improve the longevity, we can reduce the accidents, and we can have the cost benefits. That's all I would like to say. Thank you.
Thank you, Dr. Pankaj Kumar. Now we have completed first round of presentations. Now we can go for second round of presentations. And I request the other 8 participants to come on the dais, and I'll make a request from the present participants to make room for the others to come forward. And I'll also request the from the floor that whatever questions they have, they can give in writing to the participants, and otherwise they can send it to me. I will pass on to them for answering their queries. Thank you. Sorry, I am not giving you any tea break because we are already short of time, and I think we'll complete by 7 o'clock, so that cultural events we can attend after that. Thank you. Okay, right. Thank you. Just request for a group photo by the participants. Please, Dr. Madan, please come back. Sorry, I forgot.
उसको बुलाना अच्छा बस इनको ही देने का वायर लगा समझ ले इसमें ना इसमें 13 नंबर 13 नंबर ले लो यार 13 ना तुम्हारे को 3 ना 10 भी नहीं हो 10 तो भी है नहीं मेरे पास, वो भी आ जाएगी चलो 13 तो ले लो अपने फोल्डर में यहाँ पे आपका 9 है ना हम 9 निकाल लो यू आर 9 oh yes 1 minute just the name थोड़ी बार रिक्वेस्ट हाँ 9 can you just yes
Oh, that's okay. Can you just put this Dr. Deepak Manjunath or Deepak Manjunath PhD? If you want, I can type it.
yes yes
आप डाल दो जो
बीजो कौन बीजन बोला कोडलेस से वो एक काम ना करो
इसमें अनाउंसमेंट ही करवा दो एक जिनका बाकी है वो तो दे दो
मैं कॉलम दे दो जी आवे ना આપણે નાખતા છે ને કોડલેસ आप
bus.
In the meanwhile, hello. बंद हो गया क्या?
सर आप में कोई ऑडियो वीडियो
In the meanwhile, we utilize this time. I request the co-convener to make some comments. If otherwise, I'll just sum up. I mean, their one presentation was on the restoration work. I mean, such kind of landslide restorations, erosion control measures are very, innovative and can always be, found use wherever such site conditions are prevailing. And other products, most of the projects were on the polymer, modified bitumen or innovative materials, additives, which improves the riding quality, improves the pavement life as well as its quality. And they are all, promising products and must be given thought of while designing our roads, so that we can achieve economy as well as the quality of the products. Another one product which was basically on the soil stabilizer as well from the Zydex, and there are other products as well for in the next session on the soil stabilizer. These are all, very innovative products, and especially they find use because they allow you to use the marginal materials, which is one of the most important aspect, looking to the environmental conditions and protect the environment. Thank you.
Hello. Now I request to all remaining presentators, please come on stage. Sri Rohit M. Sri T.K. Subhas. Sri Satyendra Kumar. Sri Neeraj Chanda. Sri Utkarsh Bansal. Krishna Madhav, Mr. Richard, and Sri Sailesh Master.
May I request for the second round of presentations? In this session, we request Dr. Deepak Manjunath, Vice President, Design and Engineering, Indian Post Earth India Private Limited, to make a presentation on the Tindharia landslide stabilization process, which took it's a big history, and I think he will certainly tell it. It was a really challenging project.
Thank you, sir. Just let me just load up this PPT.
Ninth one?
Ninth one. So, good evening to all of you, and it's my pleasure to welcome you all to the last leg of the first day. I don't know if it happened by plot or if it happened by chance, but here we are at the end of the day, trying to squeeze through. So basically, it's my privilege to have a chance to present this very prestigious and unique case study, So this is basically a case study of a landslide mitigation project which was constructed between the years 2017 and 2020 in the state of West Bengal. And apart from being just a normal landslide project, it also combined it with the reconstruction of a road. Without going too much into the details, let me just start off. Before I start, it's very noteworthy to specify that the height of this reinforced structure was 102.8 meters, which is basically staggering. So now, just to start off with a brief history, about reinforced earth. I think you all know this, but I just want to skim through. Mostly because, the 2023 year marks the 60th anniversary of the invention of the reinforced earth technology. So the reinforced earth technology in itself was a discovery which was made by accident by the gentleman here, Mr. Henry Vidal. He was spending his time on a beach, and he observed children playing with sand, and they were basically making these sand castles. And he observed that, the height of the sand castles could be more when the sand castles were inserted with pine needles. And that's how his brain started, working, and that was basically the start of the inception of the reinforced earth technology. The technology was then patented. The patent was filed in the year 63, and now here we stand in 2023, speaking of a reinforced earth structure which is of a height of 102.8 meters. So now, just skimming through, we're going to go very quickly through the location of this project, what the site condition was, what were the problems, the solution that was presented, the design that was basically implemented, a few challenges that were faced in the execution stage, and of course, what are the advantages, in terms of reduction of backfill, conservation of water, and things like that. So basically, I think most of you remember this. Back in the year 2011, in the state of Sikkim, there was basically a magnitude 6.9 earthquake. And this earthquake was followed by a massive bout of continuous rainfall. So when you combine seismic forces with water pressure, then usually what you have is slides. So basically, there were a slew of landslides that took place in and around Sikkim and West Bengal. So basically, the project site that we are talking about is in the state of West Bengal. Dharia is the location name. And basically, the site became very critical, especially because on the bottom right of the screen, you're seeing the Darjeeling toy train. And the workshop for this toy train was basically on top of the landslide. And if the landslide location was not remediated, then what would happen is that UNESCO site would have been lost. So it was a project of national interest and also an interesting challenge. So basically, like I have already specified, this was a small town between Siliguri and Darjeeling, and what you're seeing on the right side is a blow up of the UNESCO site. So the project for us was basically remediating 3 landslides varying in heights between 35 meters to the 102.8. The problems that we faced at site started from the point when the project actually started. There was no soil that could be used which would actually comply with the specifications which were in MORTH as well as in the IRC. So there was a restriction in the supply of the amount of backfill. There was a space constraint because we all know that for reinforced earth walls, you require at least 0.7 into the height of the wall as the space. So we had no space over there. Thirdly, of course, it was a safety challenge. The heights were, huge, and the geology was not favorable. It was kind of peat mixed with silty sand and a bit of weathered rock. So the site was extremely, it was not at all in a stable condition to support the execution of works. The inclement weather was another parameter which was a real challenge. There was a continuous flow of water. There were enormous springs, and phreatic line was high. And this is a region that is basically characterized by a very high rainfall. So the presence of water was there throughout the project. And of course, we were impacted by COVID. So these were the challenges that we had to face. So now the objectives were to provide a solution for the landslide to protect the 3 locations, widening for the construction of the road, which was going to be placed on top of this wall, and of course to ensure safe construction practice, and mainly was also to reduce the excavation and filling, and of course to improve the surface and subsurface drainage. I don't have much time, I'm only 2.5 minutes off. So very quickly, we've used a solution known as TerraLink, wherein, the reinforced earth structures can be constructed even though space is an issue. So the technology is a combination of soil nailing and the polymeric reinforcements, where the polymeric reinforcements are connected to the soil nails so that the load can be transferred from the straps to the nails. That was the technology on which it worked. The technology has various kind of facings. We could either go with a normal traditional reinforced concrete panel facing, else we could also use the flexible facing which has been used here. Very quickly, the slide here shows what the situation was at the start of the project and what the structure looked like. Walking through very quickly, various construction stage photographs here, which are basically showing the various stages in which the wall was constructed. The one that you really need to focus on is on the leftmost side, wherein you have a combination of soil nails as well as drainage pipes. So the first and foremost thing that had to be made at site was provision of the soil nails so that the slope that was exposed could be stabilized. Followed by the soil nails, we also put in the perforated pipes so that there could be effective drainage. Once that was finished, we basically started with the construction of the reinforced soil wall, and the traditional practice was followed, wherein the sandwiching of the sand and the reinforcement were put in place. But here the thing was that the polymeric reinforcement was connected with the soil nail. Going through some more photographs, these are some of the slides wherein we've analyzed the stability of the wall in the execution stage. Few more photographs. Yes, just one more minute. Few more photographs here of the execution stage. Few photographs of how the nailing and the grouting was put in place. The grouting was followed by pull-out tests, which were conducted at the required frequency, so that we could ensure that all the loads were transferred effectively. Some more construction stage photographs here, which are showing the stabilization of the slope and the provision of the berms here. Again, the nailing followed by stabilization. Some more photos. I wish we had a little more time, but unfortunately I got to zip through. And I just request one more minute, sir. I'm sorry for this. This is a video that it's basically a drone shot of the structure going from the bottom till the top. The concrete blocks that you're seeing are the concrete blocks that are basically required to be installed following the installation of cable anchors, which were installed at the site. And if you really glance through the left side, you're seeing the extensive surface and subsurface drainage, which has been provided to basically channelize the water outside the structure. And with that, I would like to conclude this presentation. Thank you all for your time and thank you for your attention. Thanks.
Thank you, Dr. Deepak. Next presentation is by Bentley Systems Private Limited on digital twin for road infrastructure lifestyle. May I request Sri Rohit to make presentation.
Thank you, sir, and good evening, everyone. So I'm here to discuss a different flavor. Till now, what we discussed on the material construction, but now I am talking about the software solution. So how a digital twin for the road infrastructure life cycle can help organizations to but prior to that, to design, build, and construct the infrastructure projects. As an example, roads and the highways. So I'll start with introducing ourselves. So we as a Bentley Systems, not the Bentley Motors, we as a Bentley Systems exist almost from 1984. Okay. So we provide innovative solutions through softwares to advance the world's infrastructure, sustaining both economy and the environment for the improved quality of life. Our software services help engineers and engineering organizations for better design, build, and operate the better infrastructure. So when I say about digital twin, to understand what is digital twin, it is just a digital representation that reflects the state of physical entity, for which what Bentley offers, Bentley as a platform, which is we call iTwin platform, which is an abbreviation for infrastructure digital twin. Okay. With our infrastructure digital twin, what we can do is we can layer the data from different disciplines, different sources, just as an example from the soil, ground, geotechnical data, till the IoT sensor, AI, learning, all those IoT data. So in other terms, our iTwin technology enables the federation of data and the deliverables from engineering and design with live or near real-time data through IoT connected sensors. Okay, and it is integrated through our platform, that's our iTwin. From a conceptual phase, through planning, through design, construct and operate, so we do depend upon the data, and the data is defining your projects, and all decisions are made upon the data. Okay, and the aggregation of the digital twin data can be from multiple vendors. It's not just restricted to Bentley tools. We can pick from any CAD applications and build the digital twins for complete life cycle of the project. Okay, and our digital twin, as you can see, so it can bring from multiple CAD sources. With the APIs, you can integrate the additional information on top of your CAD models, and you can go for a better operation of your infrastructure. So to sum up, it's a digital twin solution which is open, vendor neutral and scalable platform. So when I say a digital twin, it will be in 3 phases: engineering, construction and the operation and maintenance. So now I'll speak about first on the engineering digital twin. So we have a solution called a Civil Work Suite, where we provide engineering organizations a complete tool sets to design and data transfer for the entire planning and engineering life cycle. Okay. So with the help of Civil Work Suite, you can design roads, bridges, tunnels, and any linear infrastructure projects in that sense. So I have a simple example of a case study over here. So which is our engineering digital twin. It's a project from Sistra. Yeah, fine. So it's a project from Sistra, and it's actually an Indian project. It's nowhere like outside project. So we executed this project on the coastal road, which is in Mumbai, Maharashtra, and the Sistra utilized a Bentley platform to develop the digital twin. With the help of it, so they created a 8-lane project for approximately 29 kilometers, which is in the Mumbai city. And with the digital twin technology, so they enabled the stakeholders all the deliverables prior in the hand. Okay, and they were able to cut the design modification time by half, and enhanced stakeholder understanding and excellent visualization helped to get the client approvals and further proceedings very quickly. Okay, and also with the drawing production, they saved approximately 90% of their drafting efforts. So next, coming to the construction digital twin. So this is a project again in the Maharashtra, which is for Warsaw-Bandra Sea-Link. So there it was actually, they have a challenges like it has to be executed in the deep sea, and where the logistics was a big trouble, and the construction was actually happening at the time of COVID. Okay, and what they did is they utilized Bentley's construction digital twin, which is we called as Synchro. Through that, they enhanced the project visualization and the schedule simulations. Okay, and you can see over there, so how the machine path can all simulated through the scheduling plus a 3D modeling, which is a construction digital twin. Once the engineering and construction is done, so now it will be the operation and maintenance phase. So here I have again an Indian project, so where the Odisha Work Department, which is mainly responsible for the creation of roads and building the infrastructure in Odisha state, they had a challenge. They wanted to upgrade, or they wanted to create a data for maintaining their roads. What they did is they utilized Bentley's operation and maintenance digital twin technology, which is called AssetWise. So with the help of AssetWise, they approximately mapped around 20,000 kilometers of roads and approximately 2,000 bridges. and the conditions of it, which is monitored, and they created a system called ORAMS, Orissa Road Asset Management System, which was able to predict in which year they need a funding for which type of road or which category of road, exactly with the geolocations tag like here. Okay, and through that, they actually developed a strategy for their road network maintenance. And with the recent enhancement, so we have AI technologies, right? So we have included our AI technologies into our digital twin technology. So where a simple dash cam, so almost most of the vehicles will use a dash cam. Through dash cams, we can capture the videos, and if we refer that to our digital twin, so our data can read what are the conditions. It could be in terms of road distress, whether it could be in terms of operational conditions, like it could be just a simple street light is not on. So all those conditions can be actually mapped. And also, if we develop a complete network, so you can see on the right side, so here it will indicate the conditions of the roads in a color coding. So whichever is severe, whichever is up for the maintenance, and also whichever is in the better condition. With this geo-coordinated data, you can easily map at what location you have a challenge, and you can easily figure out the solution for it. So this is all depending on just a video from the car dash cam. Okay. So with this, what I want to say is, if you go for the adoption of the digital technology in your project, why and what is the solution? So you are going to achieve improved productivity and profits. For examples, we have customers and they have saved approximately the times from planning the 2 weeks data within 2 hours. Okay. And the next one is, with the improved coordination, so you will reduce reworks. Up to 75% of rework can be reduced with going digital. And you have a scheduled, so as you saw on the construction digital technology, so it has improved schedule performance, which will improve your productivity and reduces the risk. Okay. So we have a booth set up at hall number 2, E5 and the E6. Please visit our booth and we will showcase our technology with different stages of your projects through our booth. Okay. Thank you.
Thank you, Rohit. Now may I request Sri T.K. Subhas, Technical Head from Hindustan Coals Private Limited, to make presentation on sustainable solutions for private pavement construction and maintenance.
Thank you. Good evening, everyone. I'm very happy to present about sustainable solutions for low volume roads. You know about Hindustan Colas. It's a joint venture company of Hindustan Petroleum and Colas from France. This company was formed in 1995. You know about Hindustan Petroleum, country's second largest refining company. In fact, this bitumen emulsions was invented in 1923, and Colas had a patent in 1923. To commercialize this patent, Colas company was set up. The Colas name stands for cold asphalt. So this year we are celebrating 100 years of bitumen emulsions, in fact. So since 1995, we have set up 10 plants across the country, and with 2 bitumen terminals catering to the width and breadth of the country. And a lot of product ranges, bitumen emulsions, modified bitumen, both PMBC, RMB, and RMP. And then we have colored bitumen, multiple solutions, I'm not getting into that. And we also have developed capability for the advanced characterization of the binders, mixtures, and even we do provide technical support in terms of testing the materials or characterizing the materials. And maybe we are the first company to launch a PG emulsion, performance grade emulsions. That is a new variant. We also have launched trackless emulsions. I'm not getting into what the products are because that will take a lot of time. And then we have got a specialized emulsion just to penetrate on a WMM base, which penetrates to a depth of 10 millimeters. And then we have pothole filling solutions. That is, typically the pothole filling solutions are open graded mixtures. So we have developed and dense graded mixtures for pothole filling. So that product has already been launched. And then, and as an improvement on the crumb rubber modified bitumen, we have launched a hybrid CRMB incorporating SBS along with the crumb rubber. So this is going to be a game changer in the industry because the performance is found to be at par with polymer modified bitumen versions. Now, when we are interacting with the multiple agencies, especially NRRDA, wherein the problem statement given was typically in under PMGSY 3, there are about 1 lakh kilometers of payments which are getting awarded, and about 77,000 crores is being spent on for this 1 lakh kilometers. Now, the objective is whether we can optimize these expenditures, whether we can construct durable payments with the same budget, or can we optimize the construction cost? Can we have durable payments? Typically, when we are going for a premise open graded premise carpeting followed by a seal coat, the typical life expectancy is in the range of 3 to 5 years. In fact, we were evaluating some of the projects executed by us, supplied by us, after 5 years of life. We could have mixed feedback. Some of the payments were in really good condition, some of the payments were actually gone bad. So there is something to do about that. So that is a pain area for the department as well, and there are a lot of seasonal variability. The working window is very, very limited, especially in the rural segment. And the local workforce, they are not well trained, so the technology, whatever we are implementing, has to be user-friendly, which can be adopted by or executed by the local workforce easily. And these are all very, very important because rural roads determine the economic development of a country as well. So it's from that perspective also, it is very, very important to have a sustainable solution over there. So the themes, one is, of course, on the optimization of the resources, recyclable options, and something which will control the maintenance and which will preserve the assets, and then optimizing on the life cycle cost as well. So the technology identified was chip seal for the Indian segment. Chip seal is not a new technology. This has been introduced world over in the 1960s or 50s. So it's almost 70-year-old technology, but then for some reasons, India couldn't capitalize on this technology, or India couldn't master this technology. You have voice, sound? Yeah. Let me have a quick look at this video, and then we can discuss further. So basically, the technology is quite simple. It's just a spray of emulsion followed by aggregates. Now, there are a lot of technicalities or a lot of criticalities involved. The aggregate quality has to be good quality. There should not be any fines or dust present. And the aggregate also has to be single-sized. So now getting a single-sized aggregate, getting a dust-free aggregate in India is a bit of a challenge. Somebody need to really put their hand into it and then generate that sort of an aggregate source. So that is something very non-negotiable. And then this has to be a mechanized application because uniform spray of aggregates, uniform spray of emulsion is very, very critical for success of the technology. So in fact, Hincol have invested in this technology. I'll come to that. Now, before introduction of this machinery, we are trying to undertake some of the chip seal projects in the country. Now, this is one project site wherein chip seal was supposed to be done, a G3 without fixing the local aggregates. You need to have a structurally sound base layer to apply a chip seal layer. That is very, very important. You can have a WMM surface. The WMM need to be primed mandatorily before going ahead with the chip seal applications. Now, the machinery, this machinery which is being used doesn't have a uniform spread of aggregates. The aggregate quality is very, very dusty. These aggregates are a clear no-no for chip seal applications. And in the spray bar for emulsion, you can see that it is not uniformly spraying emulsions on the surface. So this is a recipe for disaster. Whatever technology you do, this type of implementation will lead to failures. The aggregate is quite dusty. So you need to have a properly well-calibrated machinery which is capable of delivering aggregates and emulsion in the right proportions. So Hincol, we invested in this machinery. We invested about 5.5 CR for this machinery. So the first trial project we did in Kerala. So the main benefit of this machinery is that both aggregates and emulsions are being applied simultaneously. There is no delay because that is very, very, very crucial for chip seal success. The time gap between spray of emulsions and aggregates are very, very important. And this can cover up to 500 meters of length in one single pass. And the machine moves at a speed of 3 kilometers per hour. So typically 2 to 3 kilometers of construction can happen in one single day. If the aggregates are ready, machines are mobilized. That is quite a faster operation. But then here again, the surface looks very uniform, very fine. But then the feedback from the general public is that we are seeing only aggregate. There is no bitumen on the surface. So the options are either we could go for a pre-coated aggregate, or we can spray a Fox-seal emulsion on top of that, or we can go for a microsurfacing application on top of this. Microsurfacing, there are different types, type 2 and type 3, both can be applied, or we can go for a slurry seal application which will seal the surface as well. Because one of the perceived demerit of chip seal is that surface is rough. So if somebody needs a smoother surface, we can go ahead with a chip seal, microsurfacing type 1 or type 2 on top of the surface to address that issue as well. Now, this I repeat in almost every forum, because if we want to make changes, we need to critically evaluate the products, we need to critically evaluate the applications and the standards that we deploy. Because if we continue to do the same thing again and again, the results are going to be same only, there is not going to be any changes. So if you are really looking at improving the current level of road conditions, we need to bring in new technologies, and here Hincol is committed to collaborate with various departments as well as the contractors, because the machinery what we have deployed, that we are not executing on our behalf, we are executing on behalf of the contractor, because the machinery is given on a rental basis to the contractor. So we are not disturbing the system, but the technology is getting uplifted with this intervention. So the call is to adopt a mechanized chip seal, and we are there to support. Thank you very much.
Thank you, Subhas. Now may I request Sri Satendra Kumar to make introduction to ICT laboratory. But first, I think Sri S.K. Puri Sahab would like to make a brief introduction for that. Thank you.
Thank you, sir. Good evening, everybody. This is, NABL accredited laboratory for the last 30 years. ICT has established in Faridabad. And now for the last couple of years, we are trying to make it kind of a place of excellence for even the for testing of road network, which we are taking up in Bangladesh, Sri Lanka, Nepal, Tanzania, Kenya, lot of other countries also. And we have all kind of equipment here. So our colleague, Mr. Satyendra, he will be taking you through the technical specifications of all the tests and all the equipment which we have, and we are at present using it. Thank you.
Thank you, sir. So this is our brief introduction. International Consultant Technocrats means ICT. We have a laboratory as per ISO 9001-2015. It was started about 25 years ago. So whatever test we are doing, they are cost effective, accurate, reliable, and we are producing timely the results. We are doing soil test, aggregate test, cement test, bitumen, and concrete in the laboratory. In the field also, we are doing as per IRC code, MORTH, and for World Bank projects and other international projects, we are following ASTM and ASTO specification. So we are doing for builders and this. This is our vision to maintain the laboratory as a center of excellence through the use of state-of-the-art technology, and we are continuously maintaining on this also. This is our quality policy, stands committed to good performance, ISO, and International Electrochemical Constitution, EC 172025. Laboratory continues striving to improve the effectiveness of the management by familiarizing the members with policies, procedure, and documentation. Endeavor to provide reliable, accurate, timely test results, sir. So we have got accreditation also. Every year we are getting, and now we have up to 25th April 2025. Just last month we have got. So we have got the accreditation also. What is our procedure? So we get the result, we give the code number, we do the test it, we give the limit also as per MORTH. If it is not conforming, we put red marking also, and we advise some, if they need, suggestion also. So regarding facilities available, we have site work also. Recently we have completed Micronesia. They sent the sample. Our team went over there also. It is near Papua. We got the sample. It was a very marshy land. So we do the testing. So it includes digging the trial pits, extraction of core, identification of soil borrow areas, collection of sample. In the field we are doing dynamic cone penetrometer, field density, laboratory density we are doing also. These are our main 3 international projects recently completed in Myanmar also, in Bangladesh, and one Micronesia, one in Afghanistan also. These are our major national highway project. You can see most of the road we are having about 105 kilometer, 100 kilometer. Every 1 kilometer we take sample, we do borehole test. So this is the experience means our team is getting day by day. So these are the, I think everyone might be knowing, we are doing all the soil test, CBR, direct shear and consolidation, all the test. And these are the already equipment we are having in our laboratory. And these are the tests on the aggregate. I think all are familiar with this. Aggregate alkali reaction, Los Angeles abrasion, soundness, 10%. Nowadays, because if crushing value is not conforming, 10% final value is the final test. So we have a chemical laboratory also. We are doing water test. Recently, we have completed 3-4 sample. Means we do pH value, acidity, alkalinity, sulfate. So we have separated chemical division also. We have 5-6 division that I will show you at the end. These are the cement tests which we are doing: fineness, consistency, setting time, density, soundness, compressive strength. And these are the equipment we have for concrete and test for concrete. So we are going for fresh concrete, we are going for hardened concrete, we are doing NDT test also, slump test, compressive strength, flagellate strength, and we are doing mixed design both for bituminous mixes and concrete mixes also. Recently we have completed one for Bangladesh also, mixed design for bituminous mixes. So concrete testing, these are the equipment. We are having a mixing plant, curing tank, all digital. Mostly all the equipment we are getting digital because nowadays data is saved. Nokani board play with that data also. So these are, so latest code we are following, like IS 516 2021, IS 1199 2022. The last one was 1959. So these are the bitumen test also, penetration, softening, flash, ductility, binder content, specificity. Recently we have procured 3-4 types of viscosity meter also. We are finding dynamic viscosity, means absolute viscosity, and we are, means at 60 degrees centigrade, and we are finding kinematic viscosity for PMB, PG grade bitumen at 163 degrees centigrade also. So these are the equipment, sir. We are having a rotational viscometer also, or reverse flow meter. We are having a canine manning also at 63 degree. So we are finding viscosity in centipose, poise or Pascal second also, and we provide the limit also. So rolling thin film, recently we purchased, now we have purchased digital Marshall stability meter, bitumen extraction also. So this, in Micronesia we have used point load test because there was a rocky area also. We are using that also. So these are the, so equipment we are having. You can say this is the GMM we are finding. So some 1 or 2 equipment also I will show you. Just 1 minute. वो हटा दिया क्या? Just इसमें वीडियो था ना एक दो?
Yes sir, वहाँ पर ही है.
वीडियो कहाँ है? लास्ट में वीडियो था ना? लैब का वीडियो है, हटा दिया इसमें आपने क्या? ये वीडियो इसमें नहीं है ना? लैब का वीडियो था, मैंने आपको दिया. लेगी?
ये है.
नहीं है वो वीडियो इसमें, पुराना ये डाला आपने. इसमें ना मैंने भी उनको दिया B12 जो, वो कहाँ पे है? वो जो भी लोड किया. नहीं ये नहीं है, ये तो वही वाला है ना?
दिया हुआ है सर.
नहीं नहीं, अभी जो मैंने उसको हार्ड डिस्क में दिया ना, वो कहाँ है हार्ड डिस्क वाला?
यही है.
नहीं, नेगी का है, जो उसमें हार्ड डिस्क का है.
हार्ड डिस्क से लिया हुआ है सर.
नहीं हार्ड डिस्क वाला नहीं है. चलो. So we have, sir, it is the video is not here. So we have 6 division. We have soil division also. All the equipment we are having. Then we are having a concrete section also, in which we are having all types of equipment there. Then soil division also. Then bitumen extraction separately with fully exhaust fan. That also we are having. वो नेगी कहाँ है वो? तेरी हार्ड डिस्क कहाँ है? नहीं है ना वो हार्ड डिस्क, दिखा मेरे को जो मेरे से लिया तूने. वो कहाँ है हार्ड डिस्क? मेरी हार्ड डिस्क कहाँ है? वो जो मैंने आपको फोल्डर दिया वो कहाँ है? अब मेरे को हार्ड डिस्क दे दो ना.
सर हार्ड डिस्क में इसमें डलवा.
कहाँ चली गई वो?
आपकी प्रेजेंटेशन तो ही है.
यार नहीं है ना, चल कोई बात छोड़ो. आपको दिया था ना वीडियो भी हार्ड डिस्क. चलो सर, no problem. So I had given some 2 or 3 videos. It is not there. So it was showing how our laboratory works. So we have the video if it is there. नहीं है भाई, वो इसमें नहीं है. मैंने आपको वो मेरी वो कहाँ हार्ड डिस्क जो मैंने आपको जिसमें कॉपी करके दिया है, वो मेरे को दो ना. कॉपी वाला कहाँ है? मेरे को देना तो डिस्क. नहीं वो कहाँ है? आप मेरे को दे दो. नहीं नहीं, आप मेरे को दो ना, जो मैंने आपको कॉपी करके दिया वो कहाँ है? वो मेरे को देना तुम. यार वो नहीं है इसमें ना. हाँ तो वो मेरे को जिसमें डाला वो दे दो. नहीं भाई फोल्डर हटा दिया ना इसने, वही तो चक्कर. चलो छोड़ो छोड़ो कोई बात नहीं. आप मेरे को वो दे देना, वो कहाँ हार्ड डिस्क दे दो, जल्दी दे. हाँ ये मेरे को दे दो ना, या इधर दे दो, या दे दो. आपको दिया कुछ सर? 1 मिनट, जस्ट सर हाफ ए मिनट मिल गया. इसको लगाओ. अब इसको खोल, इसको खोल दो फोल्डर को. IRC का फोल्डर है.
आपका टाइम तो
जस्ट सर आधे मिनट.
आपका टाइम तो ओवर हो गया है.
निगी तू खोल में, इसमें कहाँ डाला तू? नहीं पता इसमें.
ये तो है, ये तो.
हाँ बस 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 बस. वीडियो हटाई दिए सारे से. रुक रुक रुक. It is just 2-minute video set bar. So this is our laboratory, sir. So I am just taking you online visit of my laboratory. So this is the gate, just 2-minute video, sir. So this is our staff at the ground floor. We are doing site work also near Vadodara Bombay Expressway, all testing we are doing, FWD and Faridabad bypass also, sir, we are doing that.
सर एक 2 मिनट
क्या हो गया?
कुछ कंफ्यूजन हुआ है
क्या हो तो ठीक तो ना चल रहा?
इसमें ऊपर नहीं आ रहा है ना
आपको पता फिर क्यों नहीं आ रहा?
दिस वीडियो
आ गया. So this is our lab, sir. So it is around 1,000 square yard laboratory. So this is the main gate. We start with it. So at ground floor, our staff, which is dealing with our Faridabad bypass project and Delhi Noida project, they are sitting. Our road safety persons are sitting there. This is our concrete lab, sir. Cement testing, wicket apparatus, specific gravity. This is the curing tank, all digital, sir. This is a concrete section now at the bottom. So there is a concrete mixer, table vibrator, curing tank, all digital you will find here, sir. This is the beam testing for modulus of rupture, then cube compressive strength, shear strength also we do with it. All the digital balances, sir, we are having here in our laboratory. There are soil section at the ground floor, sir, basement. So you will find all types of equipment, CBR mold. This is the CBR mold we are having for soil testing, all digital balances. After that, you will find this cone. This is the modified method also. Other dynamic cone penetrometer also, and standard compactor also, like for low volume road, liquid limit, plastic limit, cone prediction for non-plastic soil also, sir. There is the consolidation test also we are doing. The consolidation test for soil work. The all consolidation test, then triaxial shear test also, sir, for the soil we are doing triaxial shear test. Then after triaxial shear test, you will find the permeability of all the soil also. This is our aggregate section. The oven, furnace, all the sieves, crushing value, impact value, Los Angeles abrasion, flakiness index, elongation index, silt content, all aggregate equipments are also, sir, we are having there. You can measure this, the CBR mold also for finding MDD in the lab. Then electric oven, sir. So here I am taking you online to our ICT laboratory. This is the digital curing tank also. For specificity, Los Angeles abrasion for aggregate abrasion test. There is the stability bitumen also, sir. Binder extraction. You can see it is continuously being used. Anyway, its condition is like that also. Flash point, how to find the flash point of the bitumen, 220 degrees centigrade. Dynamic cone penetrometer also, sir, we are having. There is a stability mold, how to find the stability or strength of a bituminous mixes. Yes, sir. Thank you. The triaxial and all the tests, sir, we are having. So any question if you are having, sir, we are here, sir. Thank you very much, sir.
Thank you, Satendra ji. Now may I request Chadha ji, Neeraj Chadha ji, to make presentation on latest technologies, the way forward. Thank you.
सर आपका कौन सा वाला नंबर था 13th ओके दिस वन
Yeah. Very good evening, ladies and gentlemen. I am Neeraj Chadha from Complete Instrumentation Solutions. Today I'll be talking about certain technologies and will be updating you on what all we can offer to this industry. Well, earthquakes, they're very dangerous. They come mostly without any warning, and take away a lot of lives. Oh, this is a beautiful picture of Japan earthquake. 183 papers were written on this earthquake. I'm an earthquake scientist, actually. So my presentation will be more on earthquakes. Beautiful papers, scientists writing down, the radon level increased, the water level increased, and whatnot. So what are we doing? We are mapping the earthquakes after they have happened. We are giving reasons why did they happen, and then we do the research on it. Research is something which is, baseless. You can keep on writing about it. Earth is a very complex structure with around 6,450 kilometers of radius. Damn too complex. You know this, Benioff zone? Earth is made up of tectonic plates, and one plate goes beneath the other, and the stresses, they accumulate, and then eventually an earthquake takes place when it is out of bounds. So what are we doing? Earthquakes, we are always in a reactive mode. We are writing papers, we are doing research after the earthquake has taken place. How beautiful it is. This is what researchers do. But what are roads? Roads are a man-made structure. What is the thickness of road? You're talking about 1.2 meters, 1.4 meters, and in earthquakes we are talking about 6,450 kilometers. So structure of road is very well known to us. And what are we doing today? We are using the latest technologies. Network survey vehicle, which I introduced way back in 1994 in India. Mapping the distresses when they have taken place. Mapping the potholes when they have taken place. And we get into operation and maintenance, right? That's what we do. So what is the difference between what earthquakes are and what we are doing to the roads? In both the cases, we are in a reactive mode. Why are we waiting for the distresses to happen? Why can't we capture those distresses beforehand and ensure that these distresses don't happen? That is how my relation between the network survey vehicle and the research on earthquakes is. Because in earthquakes also we are in reactive mode, in roads also we are in a reactive mode. We need to move. We need to move forward. We need to use new technologies and be in a proactive mode rather than being in a reactive mode. So that is what I was talking about. Now you see this. This is a beautiful picture. If you see this video, it's a very simple video. We have a road and someone is jumping over it. What I'm trying to simulate here is that, well, there is a traffic flying by the road, but the axle loads are within the limits. So it's perfectly fine with me. What happens when we have heavy traffic, overloaded axle weights? What happens? The road breaks, the road fails. Why? Because the strains keep on accumulating, and eventually it gives away. So the strains gave away. That is how the roads get damaged. So what do we do? Once the road gets damaged, we do recarpeting of the road. So if you see that plank, we have put another plank on top of it, and then what happens? Here you go. Even when we are talking about a normal road, normal traffic plying on that road, the road will again fail because the strains have already accumulated inside. So what do we need? What is the need of the hour? The need of the hour is to capture those strains, measure those strains, and rehabilitate those roads even before the distresses have taken place. People might say, why? Yes, because they will fail otherwise. Now, if you are looking at this, the same thing happens. When I have recarpeted the road, even before the surface manifestations occur, of the distresses, my road will not fail. The cost of maintenance of the roads will come down substantially, believe me. And this is a proven fact. So this is what we do. The very first question which will be raised, why are you doing so when the road is good? But the road is not good. The surface manifestations are not there. That's it. So we need to invest at the right time. We don't have to wait for the distresses to come on the surface and then invest. If you do that, you are too late. You are too late for that. Then you will be doing the research as the earthquake scientists like me do. Write papers of the earthquake has taken place. Wonderful, beautiful papers. But the road will not last. So we need to hit the nail on the head, nip it in the bud, and ensure that, we take necessary action at the right time. In IRC 37, it is very clearly mentioned, especially for the perpetual payments when you're talking about, that the strains have to be of the level of, in tropical countries like India, you're talking about the horizontal strains at the bottom of BC to the level of around 80 microstrains, and vertical strains on the top of subgrade to the level of 200 strains, I believe so. Now, what is the need of the R? The need of the R is proactive, intelligent asset management rather than just mapping the distresses when they have happened. Let us ensure that those distresses don't happen. So if anyone is shown these two pictures, where are you going to invest your money? You will say, oh, the one where we have the potholes. Please be aware, the moment you think about it, and in 6 months, the one on the left-hand side of the screen, with the minute cracks, will be having potholes. Believe me, you are going to invest money and you'll not get the returns. So you have to put the money at the right place at the right time. That's more important. Now, how do we measure the strains? We can measure strains in different ways. One is that we instrument the road, right? And then we measure the strains at different levels. And NHAI has already undertaken a program wherein they are going to do so. And herein I'm trying to show different kind of sensors. And we have to use a weigh-in-motion system because how the strains accumulating is going to be measured through weigh-in-motion system. Because I'm worried about overloaded traffic. I'm not worried about normal traffic. I'm worried about the overloaded traffic. And that is what is causing damage to my pavements. So what are the technologies? One was instrumentation, then I use a weigh-in-motion system with it, a digital weigh-in-motion, Bimtronic with it, and now the latest from Measure. We have tied up with Measure. Lisa is here with me today. And we are now going to put up here in India a laser-based continuous falling wave deflectometer, which is not impacted by the surface distresses. Herein we are going to measure the velocities, which are converted eventually into displacements, as falling wave deflectometer does. And you are most welcome to come down to our stall and we can discuss it in details. It has been found that there's a very good match. If you look at the strains, once we measure those strains with the strain gauges, which are embedded inside the ground, and the strains, which we can also calculate through this continuous falling wave deflectometer for a simple reason, then whenever you are doing the analysis of the falling wave deflectometer, sorry, my speed is high because I can see the clock. Well, because you are in the background, when you are actually you are finding out the E-modelers, in the background you are already calculating the strains. So what you have to do? You have to measure those strains, that's it. It's as simple as that. Falling wave deflectometer does the same thing, but the only thing is it is discrete. My measure falling wave, the continuous falling wave with deflectometer is continuous. It will give you continuous readings. And here you can see a best fit. But at the same time, what is more important, I have also mentioned to IRC is, for example, in falling wave deflectometer also, it is important that you have to have a ground penetrating radar with it so that you know exactly what is the thickness of the layers. Don't go by the design thickness. Design thickness will take you elsewhere. One step in the wrong direction will take you to the wrong destination. You need to have the right data with you. Please use ground penetrating radar, find out the thickness of the different layers, feed in that data, get the right E-modelers. So there are different kinds of ground penetrating radar. So what I want to say is that you can use the combination of these technologies to get to the right solution. So with the combination of the 3 or 4 technologies I've spoken about just now, you will actually be able to measure the strains, which is very important for you. And that is what is the need of the day, to be proactive rather than to be reactive. We have got network survey vehicles, 80% of them or 90% of them have been supplied by us. The first one which I had introduced was way back in 1994. Well, the color of my hair doesn't say that because I have actually colored them. So have been into this field for good 35 years. So this is one very good equipment which we especially developed for the rural roads. You don't have to do any analysis. You just move this vehicle on the rural roads, you will get the defects in real time. This will help you in passing the bills also whether the person has actually done the job or not. The contractor has done the job or not. So you don't have to do the analysis, just move this vehicle and real time, online, on Google Map, you will get all the information. Then we have got SCRIM to measure the squid as per IRC 134-2022. And then we have got bridge health monitoring systems, both vibrating wire type and your optical sensors. Complete health evaluation is done. I can speak volumes on this, but paucity of time and time's up tells me that I have to close it. Similarly, we have got a complete range of advanced material testing systems. And then we do manufacture here mobile bridge inspection units. Number of them are in action here. So here I am. 10 minutes are over. You are most welcome to visit our stall, A4 and A5, hall number 2. Always very, very welcome. Thank you so very much for giving me a patient hearing.
Thank you, Neeraj ji. Now may I request Vishwa Samudra Holdings Private Limited to make presentation at Stable Road.
Which one? 15th. 14th is cancelled. This one.
Good evening, everyone. My name is Krishna. I'm a director at Eco Additives India Private Limited. Our parent company is Vishwa Samudra Holdings. We are into soil stabilization and FDR. Our product is a Stable Road, which is manufactured and produced out of Germany. The entire product is made out of 100% natural minerals. We're going back to the history. In 2016, when my chairman, the then MD of Krishnapatnam Port, actually preferred to come up with a great initiative to get environmental friendly technology into India. So he chose Germany will be the best bet for us. And then he thought of implementing the technology in his port itself. The port is of public-private partnership, and we implemented in 2016-17. So it's been 7 years now. And he drove the Krishnapatnam port into the second biggest private port in India until it was sold to recently to Adani's, and Mundra being the biggest port. And prior to that, we implemented, since it's a private port of his own, we thought, we experimented into a lot of areas, into all the roads with the through traffic of heavy loads of 3,000 trucks plying every day on these roads. And we didn't use DBM at all. And playing with the different kind of crust layers, with the base layer we stabilized with complete natural soils, no aggregate used. And we have used 10 mm BC, 20 mm BC, and 30 mm BC, and 40 mm BC. We wanted to study how that performs. And it's been 7 years now, and we left 50 meters to 70 meters completely without BC, and it's performing excellent. And we are collaborated with a lot of IITs and premier institutes. CRRI has done 3 to 4 years studies in different roads in port and then other areas too. We cater from right from seaports, airports. We have done the Hyderabad International Airport, and then we have done the runway, complete 5-kilometer runway, entire stretch, and taxiways, and then also we have done Goa Airport with the perimeter roads and then the parking areas. And we have done 2 ports, one being the Krishnapatnam port and then the Kattupalli Adani port in Chennai. And right from there, we fit into the state PWDs. We are into national highways. We have 4 national highways, 3 HAMs in Kerala, 1 in Jammu. And we are doing 1 green port, green seaport in Andhra Pradesh, and 5 fishing harbors. From state PWDs to rural roads, we are doing in Uttar Pradesh around 380 kilometers. We have done in Andaman, Northeast. We have seen a lot of 4-5 monsoon seasons, heavy rainfall. It's performing excellent. So getting into this technology, we fit into soil stabilization and then the full depth recycling. Full depth recycling being the distressed crust layers, and soil stabilization with the green field or the brown field. And Stable Road product is used for perpetual payments. The Germans doesn't believe that its strength alone is one factor. So they believe in strength is one factor out of 10. So Stable Road is impermeable, it's elastic, it's vibratory. All the loads get distributed into wide areas. Stresses and strains, they get absorbed within the layer. And it's all fully mechanized. Its speedy construction is amazing, and we hold several records in a day where we constructed, I think, 2.5 kilometers, lane kilometers. And we have all approvals with all the premier institutes. A lot of ongoing research and studies have been happening with IIT Hyderabad, IIT Mumbai, and IIT Roorkee, Chennai, and we have the IITR Lucknow. And I think I'm proud to announce that we are one of the biggest giving out for research and studies on these technologies, apart from the state-of-the-art laboratory what we have in Europe. And the role of additive is the key.
Anyway, so I want to talk about health. In the background, there should be, there we go. So anyway, all of us care about our physical health, don't we? A lot of us would have gone for maybe a run this morning, or ride our bike, or a walk. Not me, I need to. But, you know, if we do look after our health, it's got benefits, isn't it, for us, and certainly the public health system as well. So a key portion of our pulmonary system, pumping the blood around with our hearts, is, of course, the arteries, that bring the oxygen to the different parts of the body so they can work. And it's the same with roads. You know, we name our roads arterials because they're, as we've already seen in one presentation today, the lifeblood of the nation. So when it comes to roads, we need to look after them too. We're worried about their health. And when we look at rehabilitating them or just understanding their condition, we want to make some informed decisions about them. So typically we measure the functional characteristics or the surface characteristics of the road, things like roughness, rutting, cracking, texture and the like. And then really to get a full understanding of what's happening though, we need to see what's happening under the road surface as well. So we want to look at the bearing capacity of the pavement and the pavement composition. So typically, in the past, we've used devices like this. We've already seen some shown, these network survey vehicles. We'll have 3D systems on them, all sorts of things. And then we typically look at strength with a falling weight deflectometer or a heavyweight deflectometer. Now, they don't really go together because one's a mobile system and the other one's a static measurement. But thankfully, technology changes with time. I remember my first IRC was in 2007 at Patna, which was a great experience. And, you know, I couldn't be talking about what I'm talking about today because it wasn't a possibility. But we can basically combine these technologies today into something like this. We call it the Intelligent Pavement Assessment Vehicle. It's a big truck, but it'll actually measure deflection or give you information about the bearing capacity of the road at highway speeds, as well as measuring all those other functional parameters at the same time. And we're certainly making good use of this in Australia. So just having a look at the different components of the iPave, for short, as we call it. The deflection measurement, the strength measurement portion of it is technology from Greenwood Engineering in Denmark, which has had 20 years or so of development. So it uses Doppler sensors, and we don't have time to go into how it does that, but it also measures the other road surface characteristics the same way as a network survey vehicle does. You can compare the outputs from two and it's the same. So we've got the wheel path, roughness and texture, we've got the 3D system at the back, and we've got cameras all over it to pick up roadside assets and the like. And then today we've got the inertial component, everything spatially orientated as well. And we keep thinking about, you know, it's a big truck, what else can we add to it? And we have things like GPR now, so that not only can we locate potential areas where there might be a problem, but we can see why that problem might exist by basically using the GPR to take a bit of a picture of what's happening under the surface. So again, it's just another data set that allows us to make a more informed decision about what we intend to do. Now in Australia, this is Australia and New Zealand off to the side there. It's a little closer in this picture because of the space requirements, so we've moved New Zealand. But, you know, we can see we've used this technology to go around the major highways in Australia and New Zealand numerous times, starting in 2014 when we first brought the first iPave into operation in Australia. So there is a bit of a gap in the lower middle part, but that's getting filled in as we speak right now. Now, just as it's a little bit corny, but basically, you know, around the world there's 23 of these units. We have 3 in Australia. Another one is about to land on our shores. So we've done more than 600,000 kilometres of network survey with it. We're the world super users, if you like. So we've gone to the moon, and we're now on the return journey back to the Earth. That's how much of network we've surveyed. So just a little bit of case study then to show you what we mean about making informed decisions. Here's a picture of a pavement that has some cracks in it. If you're an experienced pavement engineer, you probably know what's happening, but maybe you want to make exactly sure of what you think is happening is actually what is happening. So here on this graph, you see the two boxes to your left. Basically, the little dots there represent cracking, and they're heavily cracked, those two pictures. But then the little graphs below the x-axis there, that's the actual deflection of the pavement. So they are pretty weak. There's a lot of deflection. So if you were just working off your functional characteristics, the road's a bit rough, there's a lot of cracking, you might think, well, I need to dig the road up and to rehabilitate it. Well, in those two cases, you'd be okay. Your decision would be all right. But if we look at the third box to the right, which shows more cracking than the other two put together, that road is very strong. So you don't need to do anything about what's the subbase, what's happening under the surface. You just need to treat the surface and fill those cracks and you'll be right, thus saving a lot of money. So we brought this technology and developed it in Australia, this iPave concept of collecting everything together to focus on roads, but now we're actually starting to get into the airport space as well. So we can run the device up and down the road, and we're collecting this data at 80 kilometres an hour, and we're doing it continuously. So we're getting this detailed picture of the condition or the strength of the runway, and we can actually locate potentially weak spots that maybe you go out and then test with a heavyweight deflectometer. But we're actually looking at ways now we can use this data from the iPave for project management work as well, instead of just going out with an FWD for the strength component. So why is it beneficial? Well, it's faster than current measuring devices. That means we can get increased coverage. For the first time, we can actually get round whole networks. New South Wales in Australia were trying to do their whole network with an FWD. It took them 7 years to do about a third of the network. And then once this device, which they paid for to bring into the country originally, we did their whole network in like 3 months. So just the fact of speed. So obviously a lower cost. And I think one of the big things to think about, and this is a picture of something that happened here in India, static testing, you can have your problems even with the best traffic management. It can be dangerous. So if we're actually travelling along with the traffic, not causing any hold-ups or the rights, there's certainly safety benefits for those collecting the data and those who are using the road. So just to finish up then, a little bit on training and standards. Of course, it's great with this technology. We want to make sure that it actually collects this data in accord with our national standards and test methods, and this certainly does in terms of the Australian test methods and other international standards. We're looking at building capacity. When we do work with people with this technology, we want people to use it to its full advantage, so we actually share that knowledge and help them to get the best out of it. So really, you get to a fork in the road here, and it depends what you want to do. You know, if you want to collect data for a particular reason, or you want to get the whole data set, or as much you can get to give you that informed decision. So just that technology now exists, as I said, 10 years ago it didn't. So we do now have that capability to measure our full networks. It applies, works in Australia, it works in Europe, it works here in India too. So anyway, if you have any questions, come and see us in hall number 1 at F3, and we'll talk to you then. Thank you.
Thank you, Richard. Now we have come to conclusion of the session, and I hope everybody has got insight into the new technologies, new materials, the technology available for making your information better and digital as well. And everybody, the presentations were so, educative and simple and understand that I don't think that there is any further requirement for myself to add it. And everybody must be waiting for cultural program to attend because this has already started. So I'll conclude it. If anything is to be added, I'll request my co-convener to make some comments on it. Thank you.
Thank you, Pandey Sahab. Thank you, Pandey Sahab. There are a very total 17 presentation was made, and all the manufacturers and stakeholders have given a very detailed presentation. I think all of you would be very conversant with it. And if any have issues, then they are on our stall. Our Gujarat is accepting these new challenges and new technologies. We have used this in PMGSY roads and new technology roads, and we have very good results, and we are also adopting in our state budget projects. We have also a World Bank, we have completed recently World Bank projects, and in that also we have used PMB asphalt. And we have also used the Ramdos survey vehicles and made a pilot project for 15,000 kilometer road, and we have collected the data and also that. So thanks to all of you, very nice presentation, and thanks all of our participants. Thank you very much.
Thank you. It's time, I think, for the mementos to be given and have a good photograph of all the presentation. Thank you.
Now I request to chairman of session to present a memento to presentators. Sri Kranti Kumar Krishna Sagar,